Welcome back. Today we will see about alpha-beta pruning algorithm in AI. So this alpha-beta pruning is a modified version of Minimax algorithm. Okay, so it's the same as the optimization technique, the same as Minimax, but little bit like next version of Minimax we can see. Here the number of states to be visited by the Minimax algorithm are exponential, which shoots up the time complexity. And some of the branches of the decision tree are useless, and the same result can be achieved if they are never visited. Therefore, alpha beta pruning cuts off these useless branches and, in the best case, cut back to the exponent to the half. Means, so in the Minimax algorithm, we have to go through all the nodes, all the path, and sometimes some of the branches or nodes are not useful because according to the algorithm some branches we are calculating the heuristic value but we are not using, so the time complexity we can reduce by using this alpha beta pruning. Here we will see according to some condition the particular branch we will cut off or prune it. So that time we can save it. So that is the advantage of alpha beta pruning. So when we are explaining with a program, it will be clear. Okay, so now you want to know about two main parameter in this algorithm, that is alpha and one is beta. Okay, and another one is infinity value. So the term I will write. Okay, so you want to know about the term alpha, so it will be mentioned as like this. Don't confuse with this. This is infinity, and the term beta will be representing as like this. Okay, beta. Okay, so alpha and beta, and you have to know about this is infinity. So alpha is the highest value. Okay, and always we will find out the maximizer. For maximizer, we are using the term alpha, and alpha will be initialized as minus infinity. Alpha will be always initializing as minus infinity. Okay, and beta is the lowest value, and always that means minimizer value is beta, and we will be initializing beta as plus infinity. Okay, this always we want to know. Okay, so the maximizer will be alpha, and the minimizer will be beta. These two we want to know, and alpha will be initializing as minus infinity, beta will be plus infinity. Okay, so here one more explanation in this particular slide. The max player will be only update the value of alpha. The min player will be update the value of beta. So we are using the backtracking. So while backtracking the tree, the node values will be passed to the upper nodes instead of value of alpha and beta. And we will pass the alpha beta value to the child node. Okay, so always from the top node. Okay, from the top node to child node, the value can pass. That you have to remember always. The value from the top node to the child node we can pass. Okay, up to down. So that we have to remember. And when we are pruning, I told you, so sometimes if the branch is useless, we can cut off or prune. So the condition is alpha will be greater than or equal to beta. So these also we have to remember. Whenever we are getting a situation where alpha is greater than or equal to b, that particular node or branch we don't want to visit. Okay. So now we will see with the problem. So this is the question. We are getting with a sample question. So like A is the root node. You can see B, C, D, E, F, G. And these are the leaf node values. Whenever you are getting a problem like this, you have to start here with the max, then min, max, like that we have to start. This is a terminal node. Okay. So if you have a 5 layer, then max, min, max, min, max, min, like that we will go. Okay, this one. So one more we have to remember. Max means what you have to find out? We have to find out the update the value of alpha. Min means we have to update the value of sorry, beta. Okay, again max means you have to invert the value of alpha. That also you have to keep in mind always. And when we are starting the problem, okay, as the first step, what here you want to find out? Maximum. So what we told in the previous step, maximum alpha will be minus infinity, beta will be plus, we are initializing alpha will be minus infinity, beta will be plus infinity. Okay. So this is a step number one. At the first step, max player will start first move from A, where alpha equal to minus infinity and beta equal to plus infinity. Okay. Now, from here, step from this we already written. Now, we will go with always when we are doing A star or AO star, whichever the algorithm, we will always stick with this right side. So now we will check the B. Okay, here also we don't know. We can't update any values because we don't know this root value. So if, for example, if I have a value here, heuristic value is there in the question, we can update with that value. Now I don't know anything up to here. Only in the leaf node the values is there. So up to that, I don't know the values which has to be compared. So that's why alpha equal to minus infinity, beta equal to plus infinity only I am writing here, because previously I told the values from the top node to down node we can pass. So that alpha minus infinity, beta plus infinity only I am passing to B. The same thing only I am passing to D2. Okay, so here also alpha infinity and beta will be plus infinity. Okay, and you have to remember what I told, max this level maximum value alpha, this one will be beta, like that we have to find out. Now step number 2, the value of alpha and beta pass down to B, correct? So, okay, where alpha equal to minus infinity and beta equal to plus infinity. Now node B also will be passing the same value to D. Okay, child D also. Now the child D can calculate the value because this D having 2 and 3. Okay, now we'll see next slide. So now onwards we will start with. Okay, now up to here we done. Okay, what we the previous slide it is alpha equal to minus infinity and beta equal to plus infinity, right? So here I came. Now this level, what I want to calculate maximum value. That means alpha I want to calculate, beta I don't want to touch. So beta is plus infinity only. Alpha only I am changing. So actually what is alpha of alpha value before? It was minus infinity. Correct. So I have to compare minus infinity and actually we will start on step here missing. So you please clearly listen. Alpha minus infinity, and first we will see this side value. So what is that value? 2. So comparing with minus infinity and 2, which is the maximum value 2. So this alpha value first I will update as 2. That step actually I missed here. So alpha will be, first time it is 2. Previously it was minus infinity, now it was 2. Okay. So after that, first I am checking the right side. Then I will check with the left side. Left side I will check. Okay, again 2 and 3 I will check. So what is the highest? Why I am taking highest? Because it is maximum I want to take. So don't confuse with the other algorithm. Other algorithm we will always check about the minimum value heuristic. But here depending on the level. So this is a maximum level. So 2 and 3, what is highest? 3 is the highest. That's why here it is written as alpha equal to 3. So after completing, we got alpha value equal to 3 and beta equal to plus infinity, that we are not touched. Okay. So when we got this 2 and 3, and it is a maximum, and from here what we got 3. So the heuristic value or the D node value is 3. That's what written here. At node D, the value of the alpha will be calculated its turn of max. The value alpha is compared with the first 2 and 3. Then the max 2, 3, 3 will be updating. Okay, so now I got 2 and plus infinity. So I told there will be a condition we are checking alpha and beta value, and if it is alpha is greater than or equal to beta, that particular node you don't want to prune it. We want to not want to visit, I told. But now this is 2 and plus in positive infinity, we can't compare. So now after this step number 3, alpha equal to 3, beta equal to plus infinity, node value is 3. Okay, now we want to go for backtracking. Now we want to calculate the value of B. Okay, so these two value is going first to by comparing by this value, I want to check the next, that is step number 4. Okay. Now in the step number 4, here what it is, minimum. Minimum means which variable we want to only see the beta value Alpha value we don't want to know, we don't want to update also. So alpha value is minus infinity. Don't confuse here. We are not passing the value of alpha to here. Why? Because here we are only checking about beta value. So alpha will be minus infinity. From where you got minus infinity? Because we start with here alpha equal to minus infinity. That value only here written alpha equal to minus infinity. We are not done. What we have to do, we have to check only the beta value, and here it is minimum, right? So actually minimum value we have to take from this. Actually, what is the beta value here? It is plus infinity. So plus infinity, and what I can compare? I can compare plus infinity and these three. Okay, plus infinity and 3 if you are comparing. Okay, so what is a minimum value? Why I taken minimum? Because here I want to go for minimum. So plus infinity and 3 if I am comparing, minimum value is 3, right? So that's why alpha equal to 3. Don't confuse. I am not taken alpha value 3 here, right? Alpha value I have taken minus infinity. I am now calculating only the beta value. So beta value when I am calculating, what I check? Plus infinity and 3 I compared. From 3 from where I got from this plus infinity and 3 I compared, I came to know 3 was the minimum. Here also don't confuse. Previously we taken the positive because it is maximum. Now it is minimum, that's why I taken. So I got alpha equal to 3 and minus infinity. Right. Okay. Now clear. Now what will do, this value I have to update now 3. So now I will update the 3 value only, because this side I am not calculating. If I will calculate this value, I can compare and I can change here, right? Now time being I don't have anything to compare, only I have 3 to count 3 is there, so I am just writing 3 here. So that step was written. Now algorithm backtrack to node B. Okay, backtrack to node B, where the value of beta is beta as the turn to minimum. Now beta equal to plus, and it will combine the available subsequent node minimum of alpha and 3, and node alpha equal to minus infinity and beta equal to 3. Very clearly written the step. So you will understand from here. Okay, now we done up to here. Okay, so the points you have to remember is simply we are not written 3. We have only the value of 3. That's why we written there. Now in the step number 5, when we came here, now we are going coming the left hand of this B. Now from here I am passing this from, I told you, from the top node I can change here. Okay, I can pass the value. So here I am changing alpha equal to, from this alpha minus infinity beta 3 I can pass here. So now alpha equal to minus infinity, beta equal to 3. Correct. Infinity and beta equal to 3, that the value from here like yeah, from the value he passed here. Now here we want to find out the maximum value, alpha value, right? We want to update. So step number 5. In the next step, algorithm travels to the next successor of node B, which is node E, and the values of alpha minus infinity and beta equal to 3 yeah, also be passed. Okay, this just passing. This is what done. This step number 5. Now, step number 6. At the node E. Okay, at the node E, the value will be changed. The current value of the alpha will be compared with the 5. Now see here, like I came here up to, right? So in the previous slide, I have alpha minus infinity, beta equal to 3. Here what I want to find out? Max. That means alpha value I want to update. Beta value no change. Alpha value if I want to update, I have to compare 5 or 9 first. I have to compare always right side. So alpha minus infinity and 5 I have to compare. And comparing this minus infinity and 5, I want to find out the maximum. So this step you see, I am comparing the minus infinity from here, minus infinity and 5 I am comparing. This step you see, I am comparing the minus infinity and 5. So what is the maximum? 5. So now alpha value equal to 5, beta equal to 3. Now next actually I checked this, right? Now again I want to compare 5 and 9 also. Correct. So 5 and 9 also I have to compare. So before comparing only the previous step, what from the previous step, yeah, from the previous I got alpha equal to 5 and beta equal to 3, right? Whatever condition, the condition is if alpha is greater than or equal to beta, Then we don't want to calculate. Now you see 5 and 3. So 5 is greater than this beta value. So this node actually I don't want. That's what written here. Now see the successor of E will be pruned. The algorithm will not traverse it and the value at the node E will be 5. Okay. So this is not done. Correct. Now I don't have this, right? So what is the E value then? Only I have now available is 5, right? So 5 I taken. Okay, so the value of E is 5 and this node is pruned. This is what step number 7. Now we'll see step number 8. So in this step, okay, and here at that time, see now I got here 5. That's why here no change. If maybe for example, if I am getting here 1 means this value will be changed because minimum, right? So it will be like 1 it will get. Now I have 3 and 5. 3 is the minimum here, minimum. So 3 only here. Up to here we done. So now we will go up. Okay, now again we have to go backtrack, then we have to come this side. Now step number 8, from the backtracking from the tree, from node B to node A. Okay, node B to node A, the value of alpha. Here what I want, maximum alpha value I want, right? Alpha value. So here alpha is 3. The value of will be changed the maximum available value. You don't think like this value is passed here. No, it won't be passed there. Actually, I want to update alpha value here. So I can compare alpha is, I know alpha is minus infinity, right? So minus infinity, I can compare only with the value 3, right? So that's why alpha is 3. It's not like I'm just passing the value. Combining the minus infinity and 3, 3 is the highest, so 3 I return. So alpha value is 3, beta will be plus infinity. Okay, that's what written here. At this next step, algorithm again backtrack the tree from the node B to node A. At the node A, the value of alpha will be changed and the maximum available value is 3. Alpha 3 comparing beta will be plus infinity. Now again, we have to come to the left side. Now from A to C, I can pass the value. Okay, so now A to C, alpha is 3, beta is plus infinity. I pass here. Now you remember, we want to check what? Beta value only we are changing here. Okay, alpha will be 3, beta value I have to change. So here, see, these two values now pass to the right successor A, which is node C. Alpha is 3, beta is plus infinity, and the same value will be passed to F also, right? Here also, like we came up to here, then we started same thing. We want to come up to here, then we have to start because here nothing. I don't have any value to check, right? So that's why I am passing the value to here. That same value will be passing to the node F2. Now step number 10. Okay, step number 10. What we done at the node F, we are comparing the alpha equal to 3 with the first we are checking with the left node. What is the left node? Is 0. 0. So 3 and 0. What is the maximum? 3 only. So alpha will be 3, beta will be plus infinity because we are not touching now that. Next, next actually what I'm checking, it is written right, then compare with the right. First comparing with the left 0, then next we are comparing with the 3 and 1. Left this 3 and 1 compared. So then 3 and 1 compare also, maximum is 3 only. So alpha remains 3, beta will be remaining plus infinity. Okay. And F value will be 1. Why? Because 0 and 1 maximum is 1. So F value will be 1. Yeah. Now step number 11. So here only 1 is there, right? So now what is the next step? We have to go to C, right? So here what next? Next here C means alpha. We are checking which value, alpha or beta value, min, right? So beta value only. So now we are coming here. Alpha is the only that previously we got. Beta from here. Beta is plus infinity. Beta will be, we are getting only the value of, from here only you will get one value, right? One value is on. So that one only we are updating here because I don't have any value this side. So I can't change. I can compare with anything. So I have only available one. That's why I written one. Okay. If I have any other one, like I have 0, then actually alpha beta will be 0 minimum. Okay, otherwise it is this one only I am written here. So that step is written here. Node F, return the node value 1 to the node C. Alpha is 3, beta equal to plus infinity. Here the value of beta will be changed. It compare with the 1. So minimum alpha and 1 is the 1. And okay. Then that's why we change the beta equal to 1. Now in the step number 12. Now we got alpha equal to 3 and beta equal to 1. I think it's clear, right? Now here what it is written, it will be comparing with the value alpha and 1, right? Alpha value and 1, and 1 is the minimum, okay? Plus infinity and this 1 is compared, so 1 is the minimum here, minimum, right? So 1 is the minimum, that's why positive infinity and 1 I compare, so 1 is the minimum, so 1 is updated here. Now here uh, alpha equal to 3 and beta equal to 1 we got. So now alpha is greater, the condition is whenever alpha is greater than or equal to beta, we don't want to go. So now we come to know alpha equal to 3, beta equal to 1. That means this side complete, no need of doing. We have to prune. This is the advantage of alpha beta pruning. So in the min-max algorithm, what we done, we are calculating each and every node. Okay, if it is useful or useless, we are comparing all and doing. But here, what happened here? We don't want, see, like this condition is there, we don't see this much time we can save. Now you see, I will the same step explaining here. Now at the C, alpha equal to 3, beta equal to 1, and again it is satisfied the condition alpha is greater than or equal to beta. So the next child of C, which is G, will be pruned, and the algorithm will be computing the entire subtree. It won't be computing. Okay, now the final answer is, now see, for the final game tree is the showing here. Okay, so here A, yeah, which path we can go, which path is the the answer, or the after the alpha beta pruning, what is the answer is from A. I can't go from here like this. We can't go because this subtree is completely gone, right? So from A, I can go to which node? I can go to B. Okay. Then from the B to D and D to this. The following is the final game tree, which is showing the node which is computed and node which has never computed. Hence, the optimal value of the maximizer is 3 from the algorithm. Okay. So don't think like it is 3. Okay, now this is a layer one, this is a minimum. So I will go from here 1. This is maximum like that. Don't think it's not the correct way. So the final answer, the workflow, the following the flow will be from A to B and B to D and from the D to this 3. So this is the maximizer value of this alpha beta is 3. Hope this is clear for you. Thank you. If you like the video, please like and subscribe.